Can hear you. Thank you very much, Xavier. As Xavier mentioned, today we will be covering the topics of auctions, net metering, tax and other fiscal incentives, and also some local content policies. Thank you again, everyone, for joining. I had a pleasure speaking to you all a couple weeks ago, and look forward to speaking with you today. So first off, what is an auction? An auction is a mechanism often where people bid or companies bid in at a certain price, and then a winner is chosen based on the quality of those bids. It isn't always price that is the key, but also other qualifications that go into place. But the design of an auction is incredibly important. And there are many different questions and factors that go into creating an auction. And in this case, we're talking about auctions for renewable energy generation. So how many winners are there? Is there just one winner, or are there multiple winners? How many rounds of bidding are there? Is there just one round and one selection of winners? Or is there one round where a winner is selected and then additional rounds until a certain capacity is met? How is the winner picked? Is it merely price, or are there other non-price criteria? Are bidders able to see other bidders' bids? So is it a blind auction, or do others know what other people are bidding? Maybe not the names of who's bidding, but can they see the prices and see the offers that are coming in? These all affect the behavior of bidders and affect the outcome of the auctions. Is the bidding live, or is it offline or sealed? So is it taking place online or in a live setting? Or are they sealed bids where you send in, similar to like a request for proposals, where you send in a proposal and then proposals are evaluated? And then what exactly does the winner of the auction win? Do they win a contract? Is there an actual contract in place saying we will pay this amount and it's signed and ready to go? Or do you merely win the right to negotiate a contract? And in that case, you wouldn't necessarily be given a specific price, but the winner of the auctions or the winner of the bids have the right to negotiate the contract with the entity that will be paying for the electricity. So the usual tender or auctioning mechanism is where a government issues a call for bids for potentially the total investment cost of a single project, or the cost per unit of electricity. So they might say, we would like to build a wind project in this location, give us your best bids. Or we would like to build 100 megawatts of onshore wind, 40 megawatts of PV, and tell us how much it would cost you to build that type of generation. And again, non-price elements can play an important role. Is there a guaranteed interconnection? Is there permitting processes in place? Are there environmental permits? Are there locations still available where the technology is suitable? These are all things to consider when there's an auction or a tender mechanism being used. Under a single winner type auction, the bidder with the lowest price typically wins a contract and then has the exclusive right to build renewable electricity generation under that specific contract. Usually, the benefits is that there's a long-term contract, 15 or 20 years, similar to feed-in tariff term contracts, and that's the reason that a developer would find an auction mechanism an attractive way to get financing for their project. However, as I mentioned, there can be multiple winners, and the winning price could be available to multiple developers. So an auction mechanism might be used as a price exploration mechanism, where what is the cheapest rate that we could get for solar power or for wind power, and then say anyone who can build at that price wins the right to negotiate a contract or wins a contract to build. So the auction mechanism can actually award projects to specific bidders, or it can be a price discovery mechanism. And again, multiple rounds are often issued until a desired capacity is awarded. If the auction is for thousands of megawatts, you are unlikely to find a developer who's the capacity to build all of those projects. And so it merely says, projects are selected over time until a desired capacity is reached. So there's been a fair amount of international experience with tenders and auctions. They've been used in Ireland, England, France, and Denmark. There are currently a handful of U.S. states that are using some form of auction mechanisms for renewables. in addition to greenhouse gas emissions, and also auctions for RECs. If some of you were on the discussion or the session 5 lecture a couple weeks ago, we talked about renewable portfolio standards and RECs. There are also auctions for RECs, and in particular solar RECs, renewable energy certificate mechanisms, to determine the prices of those quantities. And in addition, there are a number of countries, other countries that have used tender mechanisms, including China, Brazil, Argentina, Mexico, Morocco, Egypt, and Uruguay, have all done auctions for renewable energy in some form or another. So what are some of the advantages of an auction? For one, it gives the optics or the perception that it's market-based, where you have a bunch of private entities competing in an open market to determine what the price is, rather than the government setting the rate. However, the government usually chooses the capacity in which they're putting out to auction, and also we've seen auctions that have a cap in price. So we want auction prices to come in below a certain price. So there's still an element of government policy making taking place, even if there is an auction, but they do have a perception of being market-based, and sometimes folks will argue that they're more market-based than, say, a feed-in tariff, but whether that's actually true or not, it's more a perception issue, I think. There have been arguments made that it's easier and cheaper to administer. However, the flip side, some have said that it's more costly and complicated to administer, so it's sort of an open question, but that could be an advantage. An auction could be, if it's a relatively small and simple auction for a small amount of capacity, and there are good sites available, it may be an easy and cheap way to get a certain number of projects in the ground. Other advantages: there's potential for a high degree of cost efficiency because the lowest bidder is chosen. Again, theoretically, this would be the case. This assumes in the quality of the bids and the quality of the bidders that are able to participate in the auction. Policymakers can require additional non-price elements. Again, this may be choices as to where projects should be built, or where projects want to be built, or regional distribution, interconnection issues. There could be all sorts of other criteria that go into selecting the winner of the bid, rather than just whoever has the lowest price. There's also the potential to select for developers who are capable of actually getting projects, put in quotation marks, in the ground. This, again, if you're using non-price elements, you can negotiate and evaluate with developers as to what they need and what their capacity is to actually get a project built. There may be some disadvantages to auctions as well. There could be low effectiveness because of either low bids, low sort of speculative bids that there's no way a project could actually be built at that price, but they just want to try and win the auction. There could be collusion among bidders. You might get only a few participants or bidders, in which case you sort of lose the market-based dynamic. If you only have one or two respondents to the auction, you may not actually have discovered what the least cost renewable energy projects are. And in addition, the speculative bidding can take place where projects just want to fill up that spot and to try and win the right to negotiate, but may not actually have the capacity to get a project built. Auctions can create a stop-and-go development cycle if there's only one auction a year, and if the industry does not necessarily see that as a long-term market. It may encourage individual projects. It may encourage interest in developing projects, but it is generally maybe sort of an insecurity for the industry to not know when the next auction is going to be. However, you could have a regular set of auctions in place, multiple auctions a year over a certain number of years, and it could be written into legislation that those auctions will take place, and that could create some sort of security for the industry. We've seen, as I'll get into in a minute, there have been high rates of contract failure for winners and bidders in auctions. Again, it can be difficult to establish a national industry. This was the experience in the UK, because auctions can often incentivize developers to find the cheapest imported technology to win the bid based on price. And so it may not create a local market for manufacturing and development of technology. Again, you could put in content rules or requirements that if you bid in on a project, that a certain amount of equipment has to come from in country, and I'll get into that a little bit later in the presentation. Also, the nature of auctions is to create this sort of intense price competition, and that often favors the larger players, utilities, or the largest developers, international players in renewable energy project development, and also public companies. And so this really favors a certain set of projects and a certain set of developers. And so depending on what the policy goals are, if you're trying to attract new development, new local industry, and also distributed generation in various sizes of projects, auctions tend to select for only the largest and most well-established players. And there have also been arguments that feed-in tariffs are actually easier and cheaper to administer. Again, this goes both ways. I think it depends very much on the type of auction, the size of the auction, the mechanism, and if you have someone in place who knows and has experience running these types of auctions in the past. So what have been the result of some of these examples? There's very limited empirical evidence to date of the success of auctions, especially with regard to which type of auction mechanism to use. So we don't quite know what the best type of auction is. We do know that they work in terms of getting projects in the ground, but it's difficult to give very research-based empirical evidence of what type of auction to use and when to use it and what your likely success rate is. There have been comparatively few projects in the ground because of auctions versus a feed-in tariff or some of the other policies, including renewable portfolio standards and other quota systems. Auctions have resulted in a set of projects being built up to a certain amount of megawatt hours and then nothing going forward. So similarly, there haven't been examples of sort of market transformation of renewables via auction mechanisms, but they can be a very important and useful stepping stone to get some project experience and then possibly adopt a different renewable energy policy to sort of transform the market. Contract failure has been one of the largest issues with auctions. Generally, the research has shown that 20 to 30% contract failure rate should be considered the minimum. In many cases, the contract failure rates have been much higher. And in order to mitigate contract failure rates, it's important to have preconditions in place for being able to bid into the auction, to have submission fees that are significant, to be sure to request qualifications of developers, see what their assumptions are and what their financial models are if possible, and what they think they need to get a project built. There should be rules of queuing. If you're getting in line to bid, or if the bidders are selected from a series of projects that are in line, there should be specific rules as to how you get in line and how you're kicked out of line and how you stay in line. Milestone payments and deposits are generally a good idea. Performance guarantees, making sure that a project doesn't bid in and then when it's built, it's not actually producing power or was built in a site that didn't have any wind or was shaded. You want to make sure that they're going to deliver the project and deliver the energy that the project promised. And also a potential buyout option. Especially this is true if a government entity is purchasing the electricity, it may make sense for that entity to take over the project, buy out the private developer if needed. So some examples. In the UK, there were auctions during the 1990s. The government supported utility-scale renewables primarily through these multiple rounds of competitive auctions for long-term contracts. However, the overall success rate was only about 50% based on the number of projects, and about 33% of their desired capacity was built. So only about a third of the capacity that they had hoped for through the auction mechanism was actually put into the ground. And one of the issues was there were no penalties. There seemed to be a lot of speculative bidding going on, and the focus was simply on low cost, not necessarily where wind projects could be built. There was a lot of concerns of not in my backyard, or there were permitting concerns, and that had definitely came into play as to why there was large amounts of contract failure. Ireland had competitive bidding for long-term contracts, 15-year contracts. Between 1995 and 2003, they had 6 rounds. However, again, only a 22% success rate. 78% of the awarded bids did not actually get built. Again, there are important non-price elements that have to be considered, and you have to really look carefully at what projects are, what the specifics of the projects are that are being awarded these bids. France as well had a series of competitive tenders for long-term contracts starting in 1996. Their success rate was only about 32%. They moved more towards a feed-in tariff, but now they're considering moving back to some form of an auction. So again, these policies are not necessarily mutually exclusive. You could use an auction mechanism to determine, for instance, what the feed-in tariff rate is. So there's ways to play into both policies, and again, it might be useful if you want to get a small selected number of projects built to get some experience. South Africa was recently moving to adopting a feed-in tariff, but the Department of Energy quickly abandoned the feed-in tariff in favor of a central procurement policy. So they have they're putting out to a series of auctions limited to a certain amount of capacity by each technology. So they're listing the different technologies and the amount of capacity that will be they're capping based on the auction. There's been strong interest thus far. 270 respondents to the auction. 40% of the overall capacity has been auctioned already. They're requiring that projects be online by 2016. But again, it's too early to tell if the projects will actually get built. But it's a good example of a country moving forward with an auction. I guess it's too early to say if it's a good example, but it is an example of a country that's moving forward with an auction. Again, divided up by specific technologies. If you were to just say hold an auction for renewables, you may only get the least expensive renewables. And if you wanted solar or biogas or some other type of renewable, you may not get any bids. Another interesting note in South Africa is they have a black economic empowerment requirement. So all bidders are required to have that policy in place. And so that sort of leads into some local content and specific local policies that you could develop and sort of weave into the auction process. Brazil is another interesting example of a country that has used auctions. They held large-scale auctions for renewables and also non-renewable technologies. Auctions don't have to just be used for renewables, but our focus here obviously is on renewables. The contract was with a private distribution utility. The auction was administered by a government agency, and they held 3 auctions per year. The auctions have attracted a number of international wind developers from Spain and other parts of Europe, as well as North America and China, and a number of developers starting moving into the Brazilian market. Sort of one of the more interesting results is that there were enormous success they felt in terms of getting lower prices. The bids from the auction were 42% lower than their previous feed-in tariff rates. However, their analysis has sort of, when they're looking into the numbers, there is huge drop in global wind turbine prices during the time between their feed-in tariff and the auctions, and so the feeling is that a lot of that price decrease may just simply due because of the cost of turbines, rather than being inherent to the auction mechanism. But that said, that did attract a lot of interest, and they felt that they did get some low-price options. However, there's also been some recent analysis looking into the winning bidders, and the general thought is that there is expected to be between a 30 and 50% failure rate. Some of the price quotes were extremely low, and apparently some of the capacity factors were above 48 and sometimes even above 50%, which is really unheard of in terms of wind capacity, even in a high wind area. And Brazil definitely has some areas of good wind resource, but those types of capacity factors seem to be sort of out of the range of reasonableness, and so it remains to be seen what type of projects will eventually get built based on their auction. China also had a fairly successful competitive auction for wind projects. They built 12.2 gigawatts of wind in a relatively short amount of time, so in that sense it was a very successful mechanism. The lowest price bidder didn't always win. Oftentimes the average price was the successful project developer. However, some of the mechanisms, the way that China's auction was in place, it may be unique. The amount of success they had may be unique to the sort of centralized government structure that China has. They've since moved to a feed-in tariff for wind and solar. But again, it's an example of they really sort of got their industry up and running and off the ground by holding a large-scale auction. And so this may be a viable option for countries to consider. So given all this, what are some of the potential lessons learned from auctions? Continuity of calls for tender or continuity of auctions is important to avoid those stop and go cycles, making sure that people know when the bids are going to take place and they take place over a fairly long period of time. The amount of capacity shouldn't be too low or too high in terms of how much you want built. It's sort of picking the right amount of energy that you want people to bid in on to build. It's important to establish an appropriate penalty for non-compliance. You don't want people just bidding in low or just sitting in line and not building projects. However, if there are high penalty rates and the projects are still in line, they may not be able to pay their debt service. And this is one of the concerns of what might happen in Brazil, given some of the assumptions that were made by the developers. And then, as I believe I mentioned already, consider technology-specific tenders if you want a diverse supply. Similar to RPS, renewable portfolio standards that only specify renewables and have resulted in only wind projects getting built. If you just do a tender for the lowest price renewable, you probably won't see very much solar. So moving on to a different type of policy, another potential incentive for renewables is a policy called net metering. Historically, it's been applied to sort of small-scale generation, either on-site wind or rooftop solar. What net metering essentially means is that your electric meter is able to spin backwards when you are not producing, when you're not using electricity, and the system on the rooftop, for example, is producing more than you're using. And then that electricity that goes back into the grid is measured and credited to your bill, either at the entire retail rate or at just the energy rate. So typically your bill is divided into the electricity charge and then a distribution charge, and then there are generally a handful of other smaller charges. And so if you're using electricity on site, you're offsetting the entire cost of your electric bill, not just the energy portion. It's been applied in most U.S. states, many Australian provinces, Japan, Mexico, Guatemala, the Philippines, and Pakistan. And it's very attractive in markets that have time of use electricity rates. So if your electricity is priced based on the peak, it may make a lot of sense for you to put solar on your rooftop because you can offset that high peak price of electricity. So this is the map of net metering policy in the U.S. As is typical, each state is slightly different. But as you can see, that there are often limits to the size of projects that can qualify for net metering, either 1 or 2 megawatts. We have seen those caps, as they're called, net metering caps, been lifted in a number of states. But generally, there is some sort of limit to try and limit the policy only to small sort of on-site or rooftop systems. Other net metering policies have been developed. Mexico has one for solar photovoltaics only, and the limit there is 30 kW. So again, that would be a sort of smallish commercial project or a very large residential project. The Philippines doesn't have any capacity limit, and they're stated in the regulation. The utilities are required to allow net metering. And also an interesting issue that comes up with net metering is who owns the renewable energy certificates. If there's a quota system or a renewable portfolio standard in place, it's often a question if you're net metering, who owns the RECs. And the Philippines specified that the utility owns the RECs because they're essentially giving the benefit of on-site generation by offsetting that whole retail price, and in return they sort of get the RECs from that system. Pakistan has a 1 megawatt cap, and the credit is at the retail rate. So oftentimes the other option is we could see the credit, rather than being at the retail rate, we could see the credit at the just the generation rate, or sometimes called avoided cost or wholesale rate. So it's definitely a positive in terms of the policy side to have a credit at the full retail rate. That can really encourage on-site generation and renewables to get in place, because you're able to offset what would otherwise be a very expensive electric bill. So some pros and cons of net metering. Pros is promoting on-site generation or distributed generation. It often makes those individuals aware of the energy consumption, and they can oftentimes find ways to improve their energy efficiency to try and maximize the benefits of the on-site generation. The cons is that net metering alone, it can limit people to size projects to only their on-site load. They may have the potential to develop much larger projects, and that could benefit many others in the community and benefit the grid, but they might limit it to just what they're using on site. There are limits then also on the size of the market, and there may the other issue with net metering is that only sites suitable for generation can take advantage of it. So it limits the number of individual entities that can participate in the program, because you have to have, say, a south-facing roof space or a high wind site and enough land to put up a wind turbine. And also there are landlord-tenant issues. If you're renting, it's nearly impossible to convince your landlord to invest in an on-site system when the renter is the one that takes advantage of paying the electric bill. There's also a risk of load fluctuations and changes in rate classification, either because of the system or after the system is built. It could change the economics. Also, net metering policies are not a contract, and thus there's risk of program changes or termination. There's policy or legislative risk that goes into play, which all make it, net metering alone not necessarily the policy that's going to allow a lot of renewable energy generation. But net metering used in conjunction with a number of other policies can be a very powerful tool to especially promote on-site generation and DG, or distributed generation. So moving on to tax incentives. Oftentimes tax incentives can be a very powerful tool to encourage renewables within your state or country. Oftentimes they come in the form of exemption for import taxes for the equipment. This is often at an early stage of market development. There's also accelerated depreciation as a form of tax incentive, where you can write off the cost of the equipment, usually in the first 5 or 10 years of operation. That can be a very powerful financial tool, especially for large projects and for wind projects. We often see sales tax, property tax, or other corporate tax incentives or exemptions. That can be a powerful tool, and it can be a way of paying for more renewable energy. In addition, tax credits can be put into place, either a production tax credit, so an annual credit, a certain number of cents per kilowatt hour, or dollars per megawatt hour, that's credited to the electric generator, the power purchase provider, or investment tax credits, where the tax credit is granted as a percentage of the total cost of the project, and then they're able to take a credit on the taxes that they otherwise would have to pay. These can be very powerful tools and can encourage a fair amount of renewable energy development. And as is the question that always comes up with renewables, is who's going to pay for renewables? And tax credits allow a larger group of individuals to pay for the policy. It allows government and all taxpayers to pay for the policy, and not just ratepayers. So there's one example of tax credits that have been used to a fair amount of success is in the U.S. There's an investment tax credit of 30% for wind and solar and other renewables, and a production tax credit of 2.2 cents per kilowatt hour for the first 10 years of a project. It's sort of been a mixed result in the U.S., partially because the tax credits have been allowed to expire every few years, so it's created a very stop-and-go development cycle, in particular for wind. because the tax credits weren't extended for any long period of time. They've since, for solar, been extended through 2016, but the wind tax credit expires at the end of 2012. And so again, we're expecting to see sort of a stop and go cycle. Tax incentives do or can serve to limit the type of investors and projects, especially in the US. We've seen only investors with tax appetite be able to take advantage of tax credits. In order for a credit to be valuable, you have to pay a lot of taxes. And given the economic downturn, there were only a third of investors left than before the economic downturn that were able to take advantage of the value of those tax credits. So it can serve to sort of limit the pool of potential investors. And also there's been some recent analysis that suggests that, at least in the US, the tax incentive programs actually cost the government more than just handing out grants. So it's just an interesting policy analysis should be done to determine sort of what the cost would be of a grant versus a tax credit. India is sort of a good success story in terms of tax incentives. They have very generous tax incentives, 80% accelerated depreciation within the first year, which is a huge monetary plus for development. I've understood that policymakers have sort of seen it as a bridge to ratepayer recovery in order to apply, again, that burden of cost not just to ratepayers but to all taxpayers. Also, there was a requirement for PV that modules and cells be manufactured in India. This is related to what I'll talk about in a minute in terms of local content requirements. But the tax incentives in India have been employed to great success, and they've really seen their wind energy boom within the last few years. And so tax incentives within India have been a very successful policy, and it so definitely should be something on the table, especially avoiding duty taxes and import taxes. These can be very powerful tools to provide incentives for both local and international developers to enter the market. So I think India is a good example to look towards for how to implement successful tax-based policies. Again, they're moving towards adopting a feed-in tariff, but again, these policies are not mutually exclusive. Another type of incentive are lending programs. So this is different from tax incentives. So a government could provide loan funds, providing access to capital to those who otherwise might not have access. So it may be difficult for certain players within the market to get loans. The government could provide lending to these individuals. The government could provide a low-interest loan. It could be a government fund where the interest rates are low, or where they have better terms or longer payback periods, longer tenors. And this is another potential renewable energy policy program that a government could employ. And also interest rate buy down. So if a developer could show that they can get an interest rate, X from a private lender, they could take that to the government agency, and the agency may be able to buy down that interest rate. So finally, I'm going to talk about local content rules. This can particularly be an important way to provide incentives that encourage the development of local industry. As was discussed earlier with auctions and sometimes with large projects, you see foreign manufacturers of equipment just come in, whatever's cheapest. You see international developers come in, build a project, and then leave. And it doesn't necessarily create, a local industry and local, as many local benefits as could be possible. So there's often an opportunity to provide local content rules and mix those into policies, whether it's an auction, a requirement to bid in an auction, or a requirement to meet the renewable portfolio standard, or a requirement to receive a feed-in tariff rate. And there's sort of several versions of local content rules. One is you could require a certain percentage of local equipment to come from in order to qualify for the incentive program. Again, you have to make sure that you actually have local equipment in place depending on when you want the projects to be built, but you may say that the inverters of the PV system should come from in country, or the modules or components of the wind turbine blades. You could provide local tax benefits or government grants to local providers that aren't necessarily available to out-of-country developers. There could be a bonus payment, so the feed-in tariff rate could be 20 cents for anyone participating in the feed-in tariff, but it could be maybe 25 or 30 cents for someone who's a local developer. That could be a way in terms of local content bonus. There could be a lower interest rate offered for local projects. The example there is Brazil. Or you could have a local ownership requirement. You could actually tailor the program and say that the owner of the project is required to be local. It doesn't matter where the equipment comes from, but the actual developer and owner and the person that the entity that's going to take advantage of the tax credits, they have to be local. So what are some examples of local content? So Ontario had a domestic content rules. Half of the equipment for wind had to come from Ontario-based, Canadian-based companies, 60% for solar. However, you should tread with caution in terms of local content rules, for there was a WTO and also NAFTA challenges in place to Ontario's domestic content rules. So you want to make sure and think through what the implications are. There are states in the U.S. that have required local content requirements, and they can get in trouble from other states who wanted to participate. So it isn't necessarily always clear what local content rules are allowed and which ones aren't, but we have definitely seen challenges to local content requirements. Another province in Canada, Nova Scotia, had a community-based feed-in tariff. They called it the COM-FIT, and there was a local ownership requirement. In order to participate in the feed-in tariff and get the feed-in tariff rates, you had to be a local company, and the project had to be owned by a local entity. And in addition, there was an indigenous population and First Nation provisions that they received bonus tariffs for if the project was owned by an indigenous or First Nation population, which is another interesting policy tool that could be employed. Brazil also had local content rules. They had a stipulation prohibiting the import of wind turbines that had a larger capacity than 1.5 megawatts. Also, the government was able to provide lower interest loans to local developers. You had to qualify to BNDES to receive the lower interest loan, and the result has been an actual increase in local supply chain. I mean, you get international companies building factories and building supply chain within the country. That often qualifies, even if it's a foreign country. If they're actually building the projects in country, that can qualify as local content. And they've also seen a number of more developers being eligible for the lower interest rates and the BNDES financing. Finally, China had a 70% local wind requirement until 2009. However, they eliminated that local content requirement due to pressure from the U.S. government, saying that they were only promoting, they were blocking trade rules. They also have had robust tax and investment support just for their local PV manufacturing industry. And what we've seen recently is there's a Solar World Challenge before the U.S. Trade Commission, where they're alleging that the Chinese has been dumping inordinately cheap or artificially cheap panels into the U.S. and also European solar PV market. So again, local content can be a powerful tool to encourage local industry and encourage local development. But again, tread with caution, because there are international trade rules, international trade international trade agreements in place, and you don't want to run afoul of those with your local content rules. But that said, there are ways to successfully encourage local development within any of these renewable policies. So given that, we have about 20 minutes left for questions. So thank you for your attention, and I will take a look and begin to answer any questions you might have.
Okay. Hear me, the computer? Okay, so you can
Okay, so the first question is any idea of net metering installation, the number of net metering installations in the US? Difficult to get a full number on that, but it's going to be significant. Like in most, I would say most generation is probably net metering, in some form of another. All the large like utility scale projects are not net metering, but because you're able to take the full retail rate of electricity via net metering, it's a significant number of installations, especially on the residential side. I would say it's probably close to 100% of all installations on the residential side are net metered, in particular in states with high electricity rates like California and the New England states, Massachusetts, Connecticut, Rhode Island, where the retail price of electricity is 16, 16 to 20 cents a kilowatt hour. If you're able to offset that much, it makes the economics of a PV system fairly attractive. And as far as the percentage of peak generation, most of the net metering generation in the U.S. is PV, and we still have a relatively low percentage of generation coming from solar. And so I'm not sure what the percentage of peak is, but I know that Germany, for example, has about 3.5% of their solar coming from 3.5% of their energy supply coming from solar, and they've been able to eliminate the afternoon peak, which is a very impressive feat. And in terms of caps on net metering, many states do have a cap, either in terms of total installed caps or individual caps. So oftentimes there's an individual project cap. So a project can't qualify for net metering if it's over, say, 2 megawatts in capacity. And then there'll be an overall cap on net metering. For example, in Massachusetts, there's a 1% cap on the amount of net metering. 1% of the utilities load can become in the form of net metering, but not above that. And so there have been some interesting sort of market dynamics in determining how to get in and qualify for net metering before they run out of space. So local content rule question, how to make them compatible with OMC and international trade rules. There isn't a ton of guidance on this that I'm aware of. But again, I think it all depends on sort of the scale of the incentive, the amount of in-country requirements. So China's, say, 70% requirement, that seemed a bit too rich, and brought about a challenge. Similarly, Canada's 50 and 60% requirements seem to draw attention. Lower requirements may not provide that much attention. Xavier may have more insight onto some of those trade rules, and I can look into that in more detail if someone has interest. Question as to why Brazil.
Oh, go ahead.
Sorry?
Please with the next question from Juan Carlos.
Okay. So I have another question here. Why Brazil placed a floor on capacity for the wind turbines? There, I believe the question is referring to the that they didn't want projects from other countries over the 1.5 megawatt capacity, and I believe that was because that is the sort of a utility sort of scale project, and so they wanted to encourage local development of those types of wind turbines. So that's why you would require a certain capacity target as to sort of what the potential is for you to develop. So the next question is, what are my thoughts about post-2012 CDM projects in developing countries? It sort of interesting price dynamics will take place, and I think it'll be very important for each country to have supplemental policies in place. I think you really need to look towards developing some mixture of tax credits and quotas, feed-in tariff, auction mechanisms. I think all these different policies are on the table. Certainly, the widest deployed is a feed-in tariff, and there have been a lot of success with feed-in tariffs. But again, I think local policies and local focus is going to be a real important part moving forward. An interesting question here: is there a role for international development agencies to help with conducting auctions in developing countries to meet standards and promote local economy? I think this could be a very important role. That the international development agencies are often tied in with, technical experts that can either assistance could be provided for someone to come in and help design and run the auction. That can help mitigate some of the costs. And again, we don't always have a lot of good best practice examples, but we do know some of those best practices, and there definitely could be a role for development agencies to as mentioned, either conduct the auctions or provide technical assistance to get an auction mechanism up and running, or even check in and do sort of a due diligence check on the bidders. So there may not be necessarily local expertise, or if there is expertise, there may not be local time or funding to evaluate the proposals, and there's an opportunity there, I think, for the international development agencies to help fund or support those efforts. So next question is, how do you prevent quality from suffering as a result of enforcing local content rules? That's a very good point, and a good question. And again, this is the challenge of trying to develop a nascent industry, or what could be a nascent industry in your country. If you don't have PV manufacturing or wind capacity or geothermal, it can be, you can't necessarily force high quality products to exist in a short amount of time. And so I think that you would, requiring a certain amount of content, but make sure that it's a realistic amount of content. So you need to evaluate what the local manufacturing capacity and potential is, and what the time frame is, and how long it would take for developer or for companies to establish manufacturing, in country. And also, it's important, as with any policy, to have rigorous standards in place. So testing standards for equipment to make sure that they meet the highest standards. They have warranties. They are manufactured in line with international standards and engineering and safety and fire hazards, and making sure that there's no sort of a free ride given to local content in terms of those particular requirements. It shouldn't be a problem to meet those requirements anywhere. But again, I think that that's a very good point, and you don't want to encourage local content at the expense of safety or quality. So making sure that the local content requirements are also set up in a way that they meet the standards that you want for safety and efficiency and production. Okay, next question is, could I elaborate further on the reactions of private companies in relation to local content and indigenous community benefits? So I think that some private companies see it as an opportunity to move into a particular market and develop new manufacturing and create new jobs and factories and move into a market. But if it's a limited scale, they'll see it as a barrier of entry, and sort of trade rules are in place to develop open trade and sharing between countries of technology and business and markets, and so local content can sort of choke that off. For example, the challenge in the U.S. is that U.S. manufacturers of PV panels are now fairly significantly more expensive than some of the Chinese panel makers, and the same is true of German and other European solar PV manufacturers. And when they've looked at the numbers, the supposed benefits of manufacturing in China, if there's cheaper labor, or some of those arguments don't necessarily. The argument is that it hasn't stood up to analysis, and so the argument is that the Chinese government has been sort of artificially depressing the price of panels, and so therefore building a global market that way. It isn't clear if that's the case or not. I don't know what the truth is. That's what the argument has been. The counter argument has just been that the Chinese factories have massive capacity, and so they're able to really build a lot of panels in a short amount of time. It's mostly automated anyway, and so they say that that's just their cost of doing business. But it's yet to be seen how those arguments will play out. Here's a question. A few days ago, an article in Spain showed that net metering would be cheaper than buying electricity from the grid within the next 4 years. Has this happened in any country? So this is sort of the, I believe what this is getting at is sort of the grid parity question, that if you put PV on your solar, for example, on your roof, or if you net meter it, it's sort of already, it'd be cheaper to do that than to buy the electricity from the grid. And this has happened in a number of island countries. Solar is nearly at grid parity in a number of island nations because the cost of their electricity is primarily from imported diesel fuel, which can be incredibly expensive, especially in recent markets. The market price of diesel fuel is enormous. We've seen this in Hawaii, the state of Hawaii in the U.S., which is an island out in the Pacific, where their electricity rates are almost double what they are on the mainland U.S. And so grid parity is nearly there. And given the falling price of PV, there are many estimates that show within the next 4 or 5 years that is likely to take place in many places. Excuse me. The next question is any auction policies from African countries apart from, any auction policy examples from an African country other than South Africa? Not that I'm aware of, but that doesn't mean that that it doesn't exist. I've not heard of an example of another African country that has employed an auction mechanism. Next question, any experience in appropriate penalty regarding low bids? I think the key there is to have the penalty might be that if you don't get the project built in a certain amount of time, then you're out and you don't get another chance, and they move on to someone else who can get the project built, because you don't want someone sort of taking up place, taking up resources, and then not have a project built. Penalties, there isn't a whole lot of experience with penalty prices sort of working, but you might want to charge like on a per kilowatt basis, or even I think in terms of a low bid, I guess the risk is that the project isn't built, not necessarily that it is underperforming. And so I think the potentially the best penalty there would be to set a deadline for the project being at a certain milestone, and if it's not there, then it gets kicked out of line, and you give the project to someone else. Next question is thoughts on linking MFIs to RETs in order to accelerate the uptake of renewables in developing countries. Yeah, I think I think that depending on the country, depending on the policies that are already in place, it could be an effective way of again encouraging development, getting some projects in the ground so there's experience. A lot of times with renewables, it's new for the utility, it's new for the regulator, and so you need to get projects up and running so people see that they're working, they see the value, they start to recognize the benefits. And so if your current policies aren't providing or encouraging projects to actually get built, sort of employing a mechanism to get something started can be very important to show some early success, get people excited, get the industry comfortable working in the country, and also if projects haven't been permitted before, there's lack of experience in how that process works, and so the more getting a few projects up, you can say this is how the permitting process worked. These are the problems that we ran into, and you can begin to fix those. So I think that any of these policies and linking that to success in order to get some projects built, I think is very important. Another question is, as a follow-up, is there a platform for technology or best practices exchange? There are a number of international, and Xavier may be able to speak more cogently on this than I, but there are a number of international websites and organizations that track policies and help evaluate policies. REN 21 tracks policies. Futurepolicy.org is another website that sort of tracks and offers best practice guidance. Many of the development banks have best practice guides. The United Nations Environment Program and World Bank also have sort of best practice exchanges. But in terms of, it may be something that we could try and create, is some sort of more robust and interactive platform. I think it would be a useful tool, and if there isn't an effective one out there already, it's a great idea and definitely something that I would be interested in exploring. Next question is, did I look at the Nigerian landscape in terms of local content and renewable energy? It's not one that I'm familiar with, so I would love to learn more. If folks can send me examples, I would love to see them. Next question is my thoughts on human capacity development along the supply chain and its impact. I think this is in terms of developing local content. It's true that you do need to have local expertise in place, and so there's an opportunity, in line or moving in parallel with the renewable energy policy is training for local installers for solar and wind and other renewables, or training that's in place for accounting and project finance and development, like implementing those educational programs, and also local manufacturing. Those are all important pieces of sort of the renewable energy and renewable energy development puzzle, and definitely should not be forgotten. As well as training local officials as to how to permit projects and how to look into what the requirements are, what the safety requirements should be. These are all very important aspects and definitely need to be developed along with just getting the companies in place. And I think an important piece of that too is when you get projects built, or your neighbor has solar on their rooftop, or the company you work for has solar, or there's a couple wind turbines in your neighborhood. Those are all very important in terms of building awareness and sort of excitement and buy-in from the local community. So that's where even if you don't have massive utility scale projects going on, if you can get some small projects built and get some test facilities up and running, and have people tour them, and learn how the projects were built, and use as sort of training sites, those are all, I think, very effective mechanisms for building support for then what could be more aggressive renewable energy development policies.
Sorry, I will start again. I would like to conclude this webinar by first for the presentation and for the answers to all the questions. I would like to mention that the recording on the Leonardo website, that you will be also find the slides, the PowerPoint slides of this presentation on the Leonardo website, and they can download it from SlideShare. And third point, that next session will be on energy efficiency. They will start in 2 weeks, and so that was the last session.